So Chapter 1, Section 6, deals with inverses of functions. To represent an inverse, it will look like that. It's read the inverse of f of x. When you are trying to find an inverse of a function, and we'll use this f of x equals x squared plus 4. To find that inverse, you switch the x and the y, then solve for y. So in this case, we would change this to be x equals y squared plus 4 to begin with. Because remember, f of x, this represents y. So we have to just switch them. Now we solve for y. First by subtracting 4 to get x minus 4 equals y squared. And then by taking the square root of both sides. And so finally we would have y equals the square root of x minus 4. And so our inverse function, if we write it in functional form, would be the inverse of f of x is going to equal the square root of x minus 4. Now, with inverses, they'll also talk about functions that are one-to-one. A one-to-one function each x, just like in any function, each x has one y. But for it to be one-to-one, then, each y has one x. So a vertical line test determines if it's a function. A horizontal line test sorry about the interruption. A horizontal line test determines a one-to-one function. If a horizontal line hits it in more than one place, then it is not a one-to-one function. As you recall, this function here is x squared plus 4, so the graph of it is a parabola in shape, and it would be shifted up 4, so it would look like this. Well, now because you can draw a horizontal line here and hit it in this spot and this spot, this is not a one-to-one function. It is a function, but it's not one-to-one. And the significance of that is the complete inverse of this function would not be considered a function. This, though, would be, because it's only part of our drawing, because the square root of x minus 4, remember the square root of x is this graph, and if we have the square root of x minus 4, it shifts it to here, and we would draw that. Had we drawn the complete function, the complete inverse of this function, it would also include this part of the graph, which now turns it into not a function. But when we're trying to find inverses, we're only dealing with the function part, so this really isn't there. And that's why a one-to-one function is important when you're trying to find inverses. Now, looking at it just a coordinate so that you understand even more, a little review here as well. If you have a coordinate of 4 and negative 3, if a function is even, then it also has to contain a coordinate of a negative 4, negative 3, because just the x value would be opposite. If the function is odd, then it would contain the coordinate negative 4, positive 3, because you switch the sign of both things. If it is an inverse point, then it becomes 3, negative 3, positive 4, because you just switch the x and y. Finally today, proving functions are inverses of each other. One or the other of these will work, or actually both of them will work, but you don't have to do both, you only have to do one. You either take the function and then the composition of the inverse, or you take the inverse and then the composition of the function, substituting one into the other. If when you do that you are left with just x, then the functions are inverses of each other. So here we have an example. If f of x is 2x plus 5, and they tell you that the inverse is 1/2 x minus 5 halves, and you are trying to prove that they are inverses of each other, you would have to either do f composition inverse f of x or inverse f of x composition f of x. So we're going to do this one. So we would need to take this, bring it over here, and substitute it in for x. And you would get 2 times 1/2 x minus 5 halves plus 5. Simplifying this down, distributing the 2 would get you x minus 5 plus 5. And simplifying even further, minus 5 plus 5 would be just x. So now these two functions are proven that they are inverses of each other, because when you take the composition of one and the other, you get just x. Just to show you that it works the other way, if we take this and substitute it in here, you would have 1/2 times 2x plus 5 minus 5 halves. Distributing this would get you x plus 5 halves minus 5 halves. And plus 5 halves minus 5 halves turns into 0. And so you're left with just x. And so again, it shows that they are inverses of each other. Now, I don't expect you to have to do both methods. You can choose one or the other. And that is the bell to conclude this lesson. Have a nice day.